Question 14, Part B. A firework is fired from O on level ground with velocity 70 meters per second at an angle of inclination theta. The equations for motion of the firework are x is equal to 70t cos theta and y is equal to 70t sin theta minus 4.9t squared. The firework explodes when it reaches maximum height. Part A. Show that the firework explodes at a height of 250 sine squared theta meters. So first of all, we're given that y is equal to 70t sine theta minus 4.9 t squared. For y dot, we'll differentiate with respect to t, and we have 70 sine theta minus 9.8 t. At maximum height, the firework explodes, and when the firework reaches maximum height, y dot should be equal to 0. So we say when y dot is equal to 0, we have 70 sine theta minus 9.8 t is equal to 0. Solving this equation for t, we have t is equal to 70 sine theta over 9.8, which can also be written as 50 over 7 sine theta. We're looking for the height when the firework explodes, so we'll say when t is equal to 50 over 7 sine theta, y would be equal to 70 times 50 over 7 sine theta multiplied by sine theta minus 4.9 50 over 7 sine theta all squared. This can be written as 500 sine squared theta minus 4.9 outside of 2500 over 49 sine squared theta. So this becomes 500 sine squared theta minus 250 sine squared theta, giving us 250 sine squared theta. So therefore, the firework explodes at a height of 250 sine squared theta. Part II. Show that the firework explodes at a horizontal distance of 250 sine 2 theta meters from O. We said that the firework explodes at when t is equal to 50 over 7 sine theta, and at this point in time x is equal to 70 multiplied by 50 over 7 sine theta cos theta. This gives us 500 sine theta cos theta, which can also be written as 250 sine 2 theta. That's from the double angle formula. So therefore, the firework explodes at a horizontal distance of 250 sine 2 theta, that's meters, part I. For best viewing, the firework must explode at a horizontal distance between 125 meters and 180 meters from O, and at least 150 meters above the ground. For what values of theta will this occur? So we're looking for, or we require, for the distance, which we found to be 250 sine 2 theta, to lie between 125 and 180, and also for the height, which we found to be 250 sine square theta, to be greater than 150. Now, since theta is the angle of inclination, we know that theta must lie between 0 and 90 degrees, and 2 theta would be between 0 and 180 degrees. So let's begin by considering when 125 is less than 250 sine 2 theta is less than 180. So looking at the first inequality here. Dividing through by 250, we have a half is less than sine 2 theta is less than 18 over 25. Let's put in a rough sketch of the sine curve. And we're only concerned with this part since 2 theta lies between 0 and 180. So this is theta, and this is y. So y is sine 2 theta. This is 1. Okay. Somewhere here we have a half, and about here we have 18 over 25. So we're only interested in where it lies between those two, so this part here, or this part here. So let's solve for those values of theta. When sine 2 theta is equal to a half, 2 theta is equal to sine inverse of a half, and that gives us 30 degrees or 150 degrees. Keep in mind that 2 theta lies between 0 and 180. So if 2 theta is equal to 30 degrees or 150 degrees, theta is equal to 15 degrees or 75 degrees. We're also interested in when sine 2 theta is equal to 18 over 25. So 2 theta is equal to sine inverse of 18 over 25. The acute angle here is 46 degrees. And we're interested in the angles in the first and second quadrants, so 46 degrees or 134 degrees. So therefore theta is equal to 23 degrees or 67 degrees. So we say when 125 is less than 250 sine 2 theta is less than 180, theta needs to lie between 15 degrees and 23 degrees, or theta needs to lie between 67 degrees and 75 degrees. So that will satisfy the horizontal distance requirement. But we also have a vertical distance requirement, which was that 250 sine squared theta needs to be greater than 150. Dividing both sides by 250, we have sine squared theta is greater than 3 over 5. So sine theta needs to be greater than the square root of 3 over 5. We can go straight to square rooting here, since sine is positive in the first quadrant. And we said earlier that theta needs to be in the first quadrant. Okay, so if sine theta is greater than root 3 over 5, theta needs to be greater than sine inverse of 3 over 5, root 3 over 5. And that is equal to 50 degrees and about 46 minutes. So earlier we said that we had two sets of solutions for theta based on the horizontal distance requirement. But after considering the vertical distance requirement, we can only take the second solution. So we say therefore theta must lie between 67 degrees and 75 degrees.